So what we're going to use is we're going to use this liquid rubber to make our mold. It's very straightforward. All you have to do is follow the instruction. There's two parts in it, part A and part B. You first make sure that you mix the part A and then part B and then pour it in one part. Okay, so we have all the supplies over there. So if you look behind you, this is a shelf which has everything. What I'll take is I'll take a gloves, I'll take a wooden stick and a glass to actually mix it. So let's see if we can find that. Yeah, so we got multiple sticks for us. Yeah, and the second thing we need is glasses. So can you grab two glasses, one bigger one and one small one. Okay, so I got my gloves, I got my container, and I have the sticks to actually mix it. So then I'll come here. Again, I'll use this as my object. In your case, you can just use that wax thing and then put your material on top of it. So I'm just gonna open it. Yeah, these things get a little messy, so be prepared for that. And whenever you do this thing, make sure that you don't mix. For example, I have this in my gloves right now. I don't want this to come on top of it, otherwise it will fix. Usually you can put a newspaper below you, on top of your table to avoid a lot of mess. So you can also add dyes on it if you want to give it a different color. Okay, so I'm going to use this double-sided tape. Okay, so when you mix it, either you can take like equal quantity into different container, or if you are very in hurry, you can just. So for demo, I'm going to do it the right way. So can I get two more small cups? So the trick here is to minimize air bubbles, because if you have air bubbles, then that creates a lot of problem. So I usually like pour it like this, so it's very thin, and that will make sure that all the air bubbles are sort of removed when it's falling. It takes a little while. Ideally, you want to measure it. So there is a measuring scale here, but I'm not doing like a final product, so I will just eyeball it. Every mold has a different ratio. All you need to do is just read the data sheet, and that will tell you the exact ratio you have to use. Okay. Okay, so this is one part. Same I'm going to do with other part. You get some time to mix it, so it depends upon the curing time. This one is pretty large, so you don't have to like be in hurry and mix it, and then it will cure. So I'm going to just do it until here. Again, in ideal condition, you want to wait. So in this case, I'm using this. In the other case, you will use the one that you milled. Okay, once it's mixed, then you can simply pour it here. Again, the trick is to minimize the air bubble. You have to flow it from top in a very thin. Yeah, so if you do it like this, you can see all the air bubbles sort of disappears when it comes, but then it takes a billion years to finish it. Yeah, you can see there are many bubbles. Again, when you put it, you have to make sure that the geometry is such that it will come out properly. So that's why I had the flat part at the bottom. Otherwise, taking it out is another challenge. And so we have some other resins which makes like a hard plastic. You have to make sure that you use the flexible rubber, otherwise it won't come out. Okay, so that pretty much is done. In an ideal case, I'll put it in a vacuum chamber for some time, so that will let all the air bubbles escape. And then, no, that is oven. We don't have vacuum. Okay, I think this is fine now. Yeah, so we just let it stand. I think this takes 4 hours. Under heat, 15 minutes. Yeah. So this took at least 4 hours. And once you do this, then again you can make a zigzag cut. So when it will come, it will be all packed. So you can make a zigzag cut, open it, and then take it out. So that is your mold. So this is like one process. And after that, you have to cast it. So for casting, we have other materials. So if I go back here, liquid plastic. So what we use there is a liquid rubber, which will, when cured, will be a rubber. This one is liquid plastic, so it will be a solid material, like the bottle and other plastic thing. So you do the same thing. You mix two things, and then you put on the mold, and then let it dry. And once it's dry, you can just take it out, and that creates the replica of what you want. Okay? Any doubts? Questions? We have different material. We have liquid plastic. We also have dry stone and hydro stone, which can be also used for casting. So it gives a very good surface finish. So this one didn't come out quite good because we were not patient enough to actually make it. But for example, you wanted to make a car replica. What you will do is you will do the rough cut and then finish cut. And this one started melting because we didn't have a good setting. But in an ideal world with a better setting, you will get a very good surface finish, and then all this part is milled. Then you can just use this and pour your rubber mold. So when that will cure, you will get a mold for this exact car. So this is an example where you don't have a master copy, and you want to make something that you design in computer. This is one alternative to 3D printing. The other thing you can do is you can 3D print something, and if you want like 10 copy of that, because 3D printing is a serial process and it takes a lot of time, then you can print just one thing and use this method to make multiple copies. And because it's rubber, it's very easy to take it out once it's cured. And it gives you a very good surface finish also. So in 3D printer, for example, you won't get a very good surface finish. So you can. Yeah, I'll just wait until. Yeah, so 3D print won't give you a very good finish. So what you can do is you can 3D print something, then polish it, and then use this method to create multiple copies. So this will create a mold. Once that is done, then you will use this mold to create a cast, which will be your car. Some example what we do is we take like a 3D scan of an object, then wax it, mill it, and then make replica of it using this molding casting. There are different kind of liquid plastic that you can buy, like thermoplastic or thermoset plastic, and with different material property. So the problem with 3D printing is you are limited by the material you use. But here you can use any material you want because it's molding casting. Again, but it has to be 2-part and then cure into plastic. Okay, this should be fine. So tomorrow one of you can come release the mold and do the same thing which I did, but with the liquid plastic. Okay, so we have one car which is milled, and we have one other mold which is we use as a master object and then made a mold of it. Yeah, this will take almost overnight to cure, so we can't do that next process until it. But again, all you do is you use the liquid plastic, part A, part B, mix it, pour it into your mold, let it cure for overnight, and then you can just remove it out. So you will have plastic objects of the exact weight, same copy.
What all other materials do we have for casting?
I think we have liquid plastic of different property. Then we have hydrostone and dry stone. So that's more of like a plaster. So what we usually do is we use dry stone and hydrostone for development purpose because it gives a good finish and it's cheap.
Okay.
Now once you have the good finish you want and good structure you want, then you can do the final molding, final casting in the liquid plastic.
We can use that with the liquid rubber mold also.
Yeah.
And
So the difference between the liquid rubber and liquid plastic is this is flexible and that won't be flexible. So this is used for mold because then you can bend it and take it out your object. That is used for making object because the end product you want is more plastic, rigidity.
what's the mold max? 60 is it same like the liquid rubber? Or?
I think so. Everyone has a data sheet inside it, so let's see what. Yeah, so this is again liquid rubber, but this is blue in color. So this also gives a very good surface finish.
Since the wax is melting, do we have another material that we can use?
Yeah, so for wax you want to use Roland Modella, the small machine. So what you will do is you will take a block, put it in the base, and then use the glue gun to actually stick it. And then you can use that. Now that has a small bit, and it's going to do it at very slow speed. So that will make sure that the wax is not melting. So this is mainly for Roland Modella. I did it for shopboard because you guys were using it, so I just wanted to.
Shopboard instead of using this, is there anything else?
So
other
for
than
shopboard, you're gonna use foam material.
foam?
We don't have foam here because those are like a big blocks. They're very light. The only reason it wasn't shipped is because this is too big. And the reason why I use the foam is because A, it doesn't melt, B, it's very light, so you can do shipping and handling. And it's very easy to mount on shopboard and then just mill it.
Is
Yeah.
it high density thermocol, right?
Yeah. So if you are making like sculptures and big things, then you're gonna stick with foam. If you are making casing for some electronics material, then you're gonna stick with the wax.
Okay.
And the wax won't go on shopboard. Wax will go in Roland Modella. But it actually accepts STL file. So for example, once you do the STL file, then output you will do roll and mill, and then you can do wax rough cut and wax finish cut. So wax rough cut will again be 1/8 of an inch end mill, and then finish cut. We don't have the PNG file. Is there any computer anywhere there? If anyone can give me just any STL file, we can give it a try. It has a STL file?
Yeah.
Okay, perfect. I mean, we have to see because different STL files have some variations. Mesh STL. This one?
8.1 Snowflake.
Okay. So this is the STL file. Then output is roll and mill. Then let's do rough cut. Sorry. Input settings.
Snowflake.
Okay, yeah, first I do the code settings. Mod settings, okay. Then mesh STL file, snowflake, output, roll and mill, process, rough cut. Yeah, it's not taking it. I think there's some problem. So it doesn't take all the file because some files are not just designed to be rough cut. It did get something. Yeah, so if you use the right file, then it shows you something here, and then what you do is you just attach your wax in that base, and then hit the send. Oh, I think it's doing it. So the reason it's taking so much time is because it's a big file, and then it has to do all the processing. And then just send command, and it's going to mill it. So when it will mill it here, then it won't melt it because it's a smaller bit.
But only the smaller block will go into this.
Yeah, only smaller block will go. Yeah, that's why for bigger thing you need foam in Shopbot. For smaller thing you need wax, which will go here. Okay, so what you can do is not this semester. Next semester there will be Fab Academy. So you all can enroll in the Fab Academy. There Neil will go through all the parts which we did in just one day. So that will be like 1 week session on electronic design, 1 week on PCB milling, 1 week on Shopbot, 1 week on. We don't have 3D print. We have a little bit of 3D printer. So that will give you much bigger exposure. And during the class also you will make a project. So every week you will have an assignment. So you will do the design and actually make things. So that will give you more hand-on experience as well as motivation to do it.